Thank you. Hello, everybody.
Pleasure to be here. With all lights. I'm going to talk about structural steel today and value engineering on a sustainable supply chain. Just a bit of us, who doesn't know, I'm a structural engineer and I run a company called Hair Engineering. We're based on Western Australia, around 25 staff. We do structural design and facade and a lot of temporary work. So we work very closely with builders. High-rise is what we mostly specialize on. Some of our projects that we're doing across Australia, some towers in Perth, Canberra, and Gold Coast. Now, what I want to talk about today is the challenge of tomorrow. So we're going to be building city and the population will grow. So I like this sentence where they say 19th century, century of empires, 20th century, century of national states, 20th century, century of cities. I think that's very true because our cities are growing in population. Every time I come back to Melbourne, I see more buildings. And it's an interesting data. Urbanization, it was 10% of world population living in city in 1990. I was only 10 at the time. 54% in 2015. That's more than half of the world living in city now. I grew up in a small village, so I just moved to city on my 20s. 75% of the world population will be in city by 2050. That's the prediction, and I think it's true. So we're facing a big challenge here. We have to find space in city for 3 billion people in the next 30 years. So we got a big world housing challenge. That's 40% of the world. 1 in 3 person that lives in city live in slums. That's Brazil. That's rich people where they live, and that's where poor people where they live. And there's a big inequality of dwelling in city, and we want to, as engineers, we want to bridge this gap. So the challenges for us as designers and as engineers building cities, we have to bridge the gap of urban inequality. Rapid urbanization, our city have to have the right infrastructure and the right buildings to get all these people coming and live in city. But to me, the biggest one is climate change. So our city will be flooded with concrete, steel, brickwork. So if we keep building the way we are, we're just going to just keep bringing the climate change up. 0.5 of the Earth's surface is urbanized, and 80% of the global economy output came from city. So that's a huge data that show that all our strength, all our economy, all our industry, everything is on cities. So if we're going to keep building, we have to build sustainable. So there is a big challenge out there because we're building mostly with 3 materials, which is brick, steel, and concrete. There is a 4th material out there, which is wood, and I'm a big sustainer of wood. Wood is a material that sequesters carbon from the atmosphere. However, I don't think we can build 3 houses and apartments for 3 billion people in wood, unfortunately. So we have to use wisely these 3 materials here. But these 3 materials, they got high embodied energy. Brickwork is responsible for 2.5% of the carbon emission in the atmosphere. Steel, 3%, and concrete is 5.5%. So they are materials that are highly intensely energy producers. So the total CO2 emission in the world is 47% on building, 33% on transportation, 19% on industry. What people talk is only the transportation. No one talks about the global, the CO2 emission from buildings. And I'm talking about for construction, maintenance, and production of material. So it's a big component of the CO2 we put in the atmosphere. So 75% of the global energy used and greenhouse emission came from cities. So I think we have to do something about it if we're going to house these 3 billion people in the next 30 years. So the need for sustainability in design, construction, operation of buildings is a reality. This is Venice. I came from near the city. And this is like 2 weeks ago. That's like almost 2 meters of water. And 82% of the city it's been floated. I've never seen that since I've been living, so I think global warming perhaps is a reality. So at the moment, we are head-to-head collision between two issues. World housing, we need to find space for these 3 billion people, and climate change. So this is the city we want to live in the future. This is a project that is about to start in China. I don't think our city will look like that, unfortunately, but that is, I guess, a good goal that we want to try to achieve. So as engineer, we have the ability and responsibility to provide solutions that minimize the climate impact of the structure we design. I'm a structural engineer. My responsibility is to try to use less material in design of buildings. We can't just keep putting concrete and concrete just because we're lazy in our design. So there is a need for value engineering. We have to design our buildings for the right loads, for the right amount of concrete and steel and brickwork that we need. This is a research that I was reading from McKinsey & Company, and I found it quite interesting because it's showing that the global infrastructure investment will double in the next 15 years. We're going to spend $13 trillion of dollars in oil and gas, mining, and bigger infrastructure projects. Melbourne and Sydney are just flooded with infrastructure projects, so, which is great. So we're all going to be very busy designing and constructing. However, there is an issue with that. 98% of these projects are over budget and they are late. And the number is quite funny. They are over budget by 80% and they're late for about 20 months. So it's incredible because a project to be late and to be over budget means they're going to be even less sustainable because you're going to keep building, you're going to keep going with the job. So it's so the research goes on and say, why is that? And they look at the productivity and they see there's a big gap between the productivity in manufacturing and in construction. The construction has been flat, actually got worse in the last few years. So whereas the manufacturing industry went up, there's a 1.7% difference, and it's because the manufacturing industry is fully automated, so there is less human, human touch to be put on it. And so when there's human involvement, there is a lot of problems that could arise. One is poor organization, inadequate communication, flow management, contract misunderstanding, and misconnection, poor short-term planning, bad risk management, limited telemetry, and you can keep going with this. So it's all on us to be able to communicate better and to try to work with our client and the supply chain in a different way. This is from the American Institute of Architects. They give us steps to try to produce building with less embodied energy. And for me, what I can really talk about is maximize the structural efficiency. This is like it's a common goal that we need to achieve. So structural engineer for me has to achieve the maximum structural efficiency that we can to reduce material projects. So Le Corbusier in 1914, he just had the concept of the domino house, this is 100 years ago. Domino house was fought after the war where we had to reconstruct our city in Europe to create something that is modular. So this was his view, to construct a new home for all the people that lost their house after the war. So it was going to be a modular system, reinforced concrete, 6 columns, 2 slabs, stairs, and then you clad it, and then you do you fit out as you want. And I think this one here is the basics of a lot of the concept that we're still speaking today. Modularization, standardization, try to achieve repetition in our construction. So I'm going to talk about a few projects that we've done with Hera. This one here is the first project that I've been working on when I started the business 5 years ago. And it's a project that has been constructed in complete structural steel. And how this project came about is the builder came and see us, and he wanted to save cost on the job because the job was over budget, And he wanted to try to find a different way to do it. So it was already advanced in the design. There was already a design done, which was a fine design. There was no problem with that. The problem with that was there was a lot of subcontractors and suppliers. There was different construction methodology. It was quite intense to build. So the idea that we had was to remove all the subcontractor from the majority of all the concrete, the precast, the AFS, the post-tension, and just stick to structural steel throughout, and including the core, columns, slabs, everything. So the biggest innovation on this project was it was already conceived with top-down construction, and that was what we left on the job, and we just improved the use of the steel column. And we use high-strength steel to reduce the size of the column and reduce the amount of steel on the project. All the floor for both the hotel and the office were changed in steel. All steel column, steel core, which was the biggest really innovation. And because normally lift core, they build all of concrete, whereas in this project here, we use structural steel. You can see all the bracing over there. So that was like, I guess one of the first time this was done in Australia. It's very common in Europe, but people was very skeptical at the time about it. Now the sustainability of the project, because we're talking about steel, is still like a material that has an embodied energy. But it depends how much you use it, it depends how you use it. So here, by using the structural steel, we remove around 6,000 cubic meters of concrete from the project, and almost 1,000 trucks, concrete trucks, were removed from the street because the slab became very thin compared to how big they were before. So yes, we have to put a steel beam on it, but there has been still an improvement on the embodied energy of the building. And we have removed 900 tons of reinforcement from the job. This is all material that can be used in another development, and you get it for free, because you optimize the design of this building. Some of the other photo, you can see all the excavation, all the top-down construction, so it was built up and down at the same time. That's all the steel plunge column in, and then you can see all the structural steel on the project here. It's another slide. You can see all the main core fully braced up. So again, it was pretty strange to see. No one has seen it done in Western Australia before. So it was obviously, there's a lot of skeptical out there, but it works. It's done everywhere else in the world. So that's the hotel component during construction while the facade was going up. Another project that we work with Multiplex in Queensland is it's $1 billion development. It's called 300 George Street, and the development is made of that office tower at the back, which is full structural steel, the hotel at the front, and this residential tower that is currently still under construction. This is a photo from a couple of weeks ago. So the residential tower, just some facts, is the 8th tallest building in Brisbane, and is the 4th tallest office tower in Brisbane, and it's just completed construction. Constructed by Multiplex, it's a $20 million project. And we came to the project during the tender phase when there was a need to save cost on the project. So our value engineering approach was about, okay, we need to make it quicker to build, and we need to reduce material on it. So we just started to relook at how the building was behaving, how it was performing, because in high rise, what it matters is how much the building is moving at the top. So provided that you can get in the building to move the right amount, that's all you want. So we remove a lot of the shear walls, and we introduce a big steel mega truss at the top, just to stop that movement. And that made the project work. So we managed to save all this concrete and all this reinforcement by just having this idea of using this steel mega truss at the top. So the result was around 4 or 5 months in saving in program, 5,500 cubic meters of concrete removed from the project by removing all this wall, almost 900 trucks removed from the street. Again, imagine in Brisbane removing 900 trucks from the city, the amount of less congestion you're going to have. 600 tons of reinforcement was removed from the project as well. This is some of our early concept, just to see the mega truss, the steel mega truss at the top. And again, this is just an idea. An idea engineer must have, an idea that you have to put into action when you're designing. That's the mega truss over there when it was constructed, and it's to reduce the torsion on the tower on the top floor. Everything was done in beam. Very important to work with the steel fabricator and the steel supplier and the shop drawer to create that tower on paper first. And that is a huge advantage because when you're building in steel, you have like way less people on site, way less congestion. There is only 3 or 4 guys that are installing the beams. So that's it, that's all you have. You don't have like 60 people putting formwork, reinforcement, etc. It's a much cleaner site. And for safety, it's really, really good. Everything is pre-done before you go to site. It's like when you buy an IKEA flat box. You just need the instruction to put it together. That's how it is to build in like a steel tower. That's some of the photo of the mega truss when it was constructed on site. And this has been the big innovation on this project. Some of the connections are very, very heavy because imagine the wind loading that there is at the top. It needs to be stopped. All the floor is been structural steel, so it's quite simple to install. And as I said, there is no propping. It's quite quick. There's some of the photograph. You can see how clean the site is. There is no formwork. If you're looking at that second photograph, you see underneath the deck is free. So you can start already working. So that's why it's so quick to build. Columns as well were 3-story steel columns. And all the steel has been coming from Australia, which has been another big sustainable, so you don't have to track and ship the steel from overseas. On the same development, there is a residential tower, which is, this is a rendering because it's not been completed yet. That is 82-story, it will be the 6th tallest building in Australia. It will be it's the highest building in Brisbane with the Sky Tower. And it has a slender narration of 10, which for a high rise is very high, and it's quite interesting to design it. Same building, multiplex. That's some of the photo from current on site, and that's the office tower at the back complete. Again, our engineering approach removed 6,500 cubic meters of concrete. We got more than 1,000 trucks removed from the street, more than 1,000 ton of reinforcement. And what the data that is more interesting is there is a very similar building in Brisbane and compared to us, and different builders, but the same subcontractor building, and our building has like 30% less reinforcement compared to the other tower and still comply with the code. Why is that? Because the other building has just too much concrete, too much steel, and this is how we're building at the moment. So there is like a big need there for value engineering, because if we can save all this concrete and all this steel, we can build for free other accommodation. One of the biggest innovations on this job here has been like the self-climbing formwork, and that is getting to the future, getting this automation. So this formwork system here has been, it's a very expensive to buy, but when you are like the big towers, you install it once, and then this formwork system here climb every 4 days. Climb a level, and we're building a level every 4 days, which is unbelievable. So that's how you reduce time and project. But to do this, you need to be able to design to achieve the floor cycle. So the engineer has to work very closely with everyone, form workers and suppliers and builders to achieve that, because designing paper is one thing, how it's getting built on site is a different one. So you need to know nuts and bolts of how system works in order to be able to deliver. There's some of the photograph of the system that is climbed. It's 3-story ahead of the last slabs, and that's just a photo from the office tower when they were installing the steel roof. That's again some of the photograph. And wind tunneling, very important, and very important to do wind study in building to get the comfort and to get the right amount of load on your building, so you avoid to over design. So we're using wind tunneling for tall towers, and we have to keep doing that. And also, it's going to give you a realistic view of how much wind is going to hit your building. On the commercial tower at 300 George, We did wind tunneling on the roof, just to design the crown of the roof, which is 200 meters up in the air. If we would have used the code, we would have need 200 tons of steel, because we did local wind tunneling. The cost was not high. We went from 200 tons to 120 tons. We saved 80 tons of steel just because we did wind tunneling. That's incredible, because those 80 tons, once again, they would have been in that tower, whereas we can use it to build a school, for example. That's some of the images from the tower. It shows like all these big columns on the perimeter that stop the building from sway. It's like when you go skiing, and you have the sticks to balance the movement of the building. They call mega columns, and the concrete wall connecting, they call outrigger. This concrete wall used to go all the way up, whereas we stopped the wall and we just have the wall like in 4 different spots. So that's where the majority of the concrete was saved. That's some of the photograph of how this building is standing up against the wind loading. Now, to conclude, for me as a structural engineer, I think we build in city, we're gonna build tall. That's the way the future is gonna go. Even in Milan, in Italy, where I'm from, there not used to be many high-rise over there. I just been to the city 2 years ago. There's a lot, because people is moving to city. It's obvious now. So we're gonna build up. We can't build flat. So high-rise, we need to understand how to do it. I think there's still a lack of understanding of how this is done. And use the right material. Steel, concrete needs to be used wisely. You need to keep things simple. Architect and engineer needs to work together to get columns straight, avoid transfer. That is gonna really shorten your time, because as soon as you complicate the building, it's gonna take more, and then it's gonna go over budget, I guarantee you. Speed of construction, just an example, just show you on 300 George, that formwork system. That is, it reduced the cycle from 7 days to 4 days. That's 6 months in program. We saved $20 million in those 2 projects because of the program that was saved and the material was removed. And we used to use advanced technique for design, analysis technique, software, and we need more advanced code. The code are very conservative at the moment. We need more advanced code. That's very important. And builder, engineer, client, and the supply chain has to work together. We do a lot of temporary works. We work with builders and the subcontractor all the time, and it's really, really improving the efficiency in our design. And for the material and supply chain, we have to specify more high-strength steel, because it's just less steel, just stronger, so you need less. And we need to use high-strength reinforcer, just came out, and high-strength concrete, and again, work closely with subcontractor and the supply chain. Thank you.